Hello everyone. Now we'll have an introduction to wireless communication. The wireless communication is called as wireless communication because we are not using wires. So it is referred as wireless communication. So just we have a basic communication system. If you take a basic communication system, it has a transmitter and a receiver and a channel. So the channel may be a wired channel or a wireless channel. So when we consider this channel to be a wireless channel, that is a free space, then we represent that system as a communication system. So the transmitter, before the transmitter, we have the input message, what we transmit. So we'll just see a small overview of all the blocks which are present in the communication system. The source is nothing but any device that originates a message. A message can be of a human voice, a television picture, and a data. The input signal is transduced into an electric waveform which is referred as the baseband signal or the message signal. That message signal is transmitted through the transmitter after modulation. So for the efficient transmission, the modulation is done and the transmitter section comprises of a pre-emphasizer, a sampler, a quantizer to convert analog data into a digital, and a coder for coding, and then a modulator, and it transmits the signal. A channel is a medium through which the transmitter output is sent. So if it is a wire, it may be a wire, example a coaxial cable or an optical fiber cable, or a wireless channel which we refer as a radio link. So basically the channel are of two types, wireline communication and wireless communication. So that signal is received by the receiver, and the task of the receiver is to extract the signal from the distorted and noisy signal. And the receiver comprises of a demodulator, a decoder, a filter, and a de-emphasizer. The output received is originally converted to in its original form from the electrical signal, and the goal of the physical layer communication is to transmit the information accurately and efficiently. So here it is given power and spectrum. So for any communication system, its efficiency is weighted by the spectrum efficiency, how effectively the spectrum is utilized, that is the frequency is utilized, and how effectively the power is utilized. The power consumption must be minimal. So a communication system is valued by its power efficiency and spectrum efficiency. And when going for wireless communication, we have n number of wireless communication. Wireless means the message is carried over the air interface. So example of few wireless communication systems are cordless telephone, which was used initially. The cordless telephone, it will comprise of a radio set to connect a portable handset, and the handset can be moved to a certain distance, say for example few tens of a meter. And second, the example is your paging system. Earlier we used a paging device. We can page information from every base station to the user, to a subscriber. Only messages can be sent and no voice signal can be sent. And the next example is cellular telephone system, cellular systems. This cellular system, it provides a wireless connection to the available public switched telephone network for any subscriber or a user within the radio range of that system. So the wireless communication systems is classified as standards. So depending upon the deployment, it is classified as 1G, 2G, 3G, 4G. It means first generation, second generation, third generation, fourth generation, and now it goes to fifth generation, etc. So when you go for first generation wireless system, it was deployed in early 1980s and it was purely analog. So first generation systems are purely analog transmission techniques, and it uses frequency division multiple access for multiple access and frequency modulation for modulation. and the system capacity is low because it is based on frequency division multiplexing and FM modulation. So the supported data rate by the first generation wireless system is approximately 8 to 10 kbps. And the representative standards which was standardized worldwide was the AMPS, which is referred as Advanced Mobile Phone System, which was developed by AT&T Bell and was deployed in the year 1983. It used large cell and a very large omnidirectional base station antenna. And the disadvantages is the number of users are limited, and it was used worldwide, especially in US, South America, China and Australia. And another representative standard of first generation is ETAX, which we refer as European Total Access Communication System. Almost it is similar to AMPS, except that the channel bandwidth is 25 kilohertz instead of 30 kilohertz in AMPS. And coming to 2G wireless system, it was deployed in midst of 1990s, and 2G was purely digital. First generation was purely analog, but second generation was purely digital, and we refer as digital transmission system. And higher data rates was achieved using the digital voice coding and digital modulation, which provides all the advanced call capabilities. And the capacity was increased by 3 times compared to the first generation system. And this 2G wireless system supports mainly voice-centric services and limited data services like SMS, fax, etc. And the data rate supported by the 2G systems was in the order of 10 kilobits per second. And the representative standards of 2G was the worldwide popular standard which we referred as GSM, Global Systems for Mobile Communication. It is basically a TDMA system which serves as a pan-European cellular service and provides a wide range of network services like phone service, fax, SMS, and supports data rate of 24.7 kbps. And another standard is USDC, which is called as IS-136, Interim Standard 136, which is developed by United States Digital Cellular. It is also a TDMA system, which is backward compatible with AMPs. It supports 6 times more user with improved performance, and it shares the same frequency. That is, it uses the principle of frequency reusing by using proper planning and base station as AMPs. And it provides access to a VPN, supports short messages, and supports data rates of 48.6 kbps data rate. And another 2G representative standard is IS-95, that is United States Digital Cellular Standard. It is a CDMA standard, and it is designed to be again compatible with the AMPS through using CDMA or AMPS dual mode phones and base station. The capacity is approximately 8 to 10 times that of AMPS, and which supports a data rate of 14.4 kbps data rate. So with the enhancement to the 2G system, it came a 2.5G system which provides a high-speed data communication which is capable of providing a continuous connection to the internet. This 2.5G representative standards are EDGE, that is Enhanced Data Rate for GSM Evolution, which provides a data rate of 384 kbps by using an improved modulation. The modulation which is used in EDGE is 8 PSK instead of Gaussian minimum shift keying in GSM. So that modulation has enhanced the data rates from 24 kbps to 384 kbps. And also it has a relaxed error control, which is also referred as Evolved General Packet Radio Service, EGPRS. And the another standard of 2.5G is GPRS, which we all know, which is referred as General Packet Radio Service. This is completely depends upon the packet switching technology. Since we are delivering it as a packet, the data rate supported is very high. So based on GSM, the GSM standard follows a TDMA standard by allowing multiple slots of GSM radio channel to dedicated individual user, it supports a data rate from 56 kbps to 114 kbps. And this nature provides a continuous interconnection for the internet for mobile phone and computer user, and also it is easy access to the virtual private. And another 2.5 G representative standard is CDMA1, that is IS 95B, interim standard 95B. It provides a high-speed data access on a common CDMA radio channel by dedicating multiple orthogonal user channels for specific user or specific purposes. And it supports a data rate of 115.2 kbps, a higher data rate, and compared to CDMA1, GPRS and Edge, the Edge provides much more data rate, which is 384 kbps. And the next one is 3G wireless system. So the 3G wireless system was developed on the objective of obtaining a global standard. So the work was started on of the objective to create a global standard which can provide a higher transmission rate and also support multimedia services. So this supports multiple megabit internet services with simultaneous voice and data access with multiple parties at the same time using a single mobile handset. So this is a exclusive important characteristic features of 3G wireless system, and the data rate supported comes around 2 Mbps and the bandwidth is in the order of megahertz. And the 3G wireless system provides a global roaming seamless communication. That is, seamless communication means a continuous communication without any discontinuity during the communication. Wireless access is obtained from anywhere on the earth. And this 3G wireless system was supported by two organizations, which is 3GPP and 3GPP2. It is a worldwide standard organization which is established to gather global expertise and participated by almost all the very big leading companies to create a global standard. And this 3GPP, it is the development of 3G wireless standard was backward compatible to GSM, IS-136, GPRS, Edge, etc. Whereas 3GPP2 is basically depending upon the CDMA system. So it was backward compatible to IS-95, which is a CDMA standard, and also CDMA1. So 3GPP was based on GSM and 3GPP2 was based on the CDMA. The 3G representative standards was initially the UMTS, Universal Mobile Telecommunication System. It is a wideband CDMA which has a bandwidth of 5 MHz and it's based on the network fundamentals of GSM or Edge. And it is backward compatible with GSM, IS-136, GPRS and also Edge, which can support a data rate of 2 Mbps. And what is the requirement here is a new RF equipment must be deployed to provide a network access or communication. And another representative standard of 3G is TD-SCDMA, that is time division synchronous CDMA system, which was proposed by the China Academy of Telecommunication Technology and Siemens Corporation. This TDMA system, it depends upon the existing GSM infrastructure and allows the 3G data access by adding high data rate equipment, that is smart antenna, by providing a smart antenna at each GSM station, which supports a data rate of 384 kbps of packet data. And 3GPP2 works with CDMA. So the 3G standard of CDMA is CDMA 2000 3G 1x to 3x. It uses the same bandwidth or 3 adjacent CDMA channels, which will provide 3 times bandwidth as that of a single IS-95 to provide an instantaneous packet data access at 144 kbps or 2 Mbps. So here the advantages